Hello, this is Miss Linzmeier, and we are in topic 4, lesson 4, day 1. Today we'll be adding, subtracting rational expressions. And then our vocab word, which won't happen until tomorrow, will be compound fraction. So we'll be working with sums and differences as we've recently been multiplying and dividing. So what I would like you to do first is I want you to add those three fractions together. Okay, we have Tio, who claims that the common denominator of the sum is 2 plus 3 plus 9, which would give us 14. Evander claims that it's 2 times 3 times 9. Is either student correct? Why or why not? And I actually want you to find the sum. So go ahead, pause the video, and do that for me. Okay, welcome back. And so you should have decided that Evander was the one correct with the 54. However, there's actually, right, when we add these fractions together, this is one common denominator, but a lot of times we want to find the least common denominator, which would be what number does all three of those, 2, 3, and 9, go into evenly. And that would actually be 18. So just as a recap, how do we combine, how do we add fractions, or subtract for that matter? Well, we want all of these to have a denominator of 18. So remember, this is where we're going to change. So I'm going to multiply both the top and bottom by the same amount. Now, each fraction will be a different amount because it takes a different amount to get to 18. But remember, 9 over 9 is still 1, so we're not changing it. This would be 6 and 6, and this would be 2 and 2. So we would get 9 over 18 plus 6 over 18 plus 2 over 18. We get 15, 16, 17 18ths. Okay, and so that is your answer. The method would be similar to Evander with finding a common denominator. 54 would work. We just have to simplify. Okay, so that is what we are going to be doing today, right? Same concept, but how do we make a common denominator with rational expressions in order to add and subtract? So I want you to write down example 1A. And we are going to find the sum. So in order to add or subtract, right, we need a common denominator. And I want you to think of these as one group. Okay, so they both have a common denominator. These are exactly the same. So what happens is we are going to add the numerators, but this does not become 2x plus 8. Remember, the common denominator, that is what stays the same. Just like when we added our 9/18 and our 6/18, right? We would get 15/18, not 36. We don't add the 18 and 18. So not our 15 over 36. Okay, but this then is actually our answer because remember, these are groups. I cannot just simplify my x's. Okay, so there's my answer. All right, go ahead. And so in here, right, a little bit different. Again, as you're writing, I want you to think, okay, do we have a common denominator, right? So sums. In order to add or subtract, we need a common denominator. So what you're always going to want to do is try to factor first if we don't see a common denominator. This is not the same as of right now, so let's go ahead and try to factor this. Remember, again, this is a group. When there's only 2, you should be looking for your GCF, which in this case would be x. And if we factor out an x, we should indeed get our x plus 3. which means that my common denominator is indeed this x parentheses x plus 3. And so now I can add both of these on the top. Now a lot of times I like to just think of this one big fraction so that I can see it. So it's 2x plus 1 plus the 3x minus 8. Now we're going to combine like terms on the top. So we got 2x and 3x gives us 5x. 1 minus 8, we have a negative 7. And then that is all over my x plus 3. Now, a lot of times we're going to want to double check. There's nothing else that can go in that can factor out, so these aren't going to cancel out. That is our answer. Okay. Now, I want to talk about bringing in what we had done in the past. If I talk about what is our domain, right? What do we do for our domain? And that would be setting our denominators equal to 0 and solving this. So our domain, x cannot equal 0 or negative 3 if I bring that in. Okay. Okay, so what happens when we don't have a common denominator? Okay, then we're going to have to do these two steps first. So we're just going to practice in general finding what we call is the LCM, the least common multiple, or in other words, the least common denominator is what we're going to be using it for. Okay, so first let's just practice factoring these so that we can see, okay, what is our least common multiple, meaning what does everything go into. Okay, so this first one, right, if we factor this, I want you to think of this as there are actually two of them there. If we factor this, right, regardless of how you need to do it, what multiplies to 6 adds up to 5. That gives us 2 and 3. And so we would have x plus 2, x plus 3. Now, what is the least common multiple? Meaning everything has to go in. So I'm going to first start with the first one. No matter what, everything has to be included. So I'm going to write both of those down. Because in order for this to be true, to go into it, I would need both of these. Okay? Because I can't take anything away. Now, all we're going to do is look to the second one and see, okay, what do we have to add to this? Well, this is already taken care of. There is one of them there. This is not, so that is what I need to add. So this is what we call the least common multiple. What would go into everything of these two combined. Okay, so I want you to pause the video and try this one on your own. Okay, welcome back. So we're going to show each one of these factored. This I should be able to factor out in x. I get x squared minus 9, which means I can factor that into this. We have my x squared minus 2x minus 15. You should get x minus 5, x plus 3. And lastly, this one, when I factor it, I should factor out an x and get x minus 5. Okay, now our least common multiple is we are looking for what goes into all of them. So the first one is a given. Whatever is in the first one, we have to put. So we have the x minus 3, x plus 3. Okay, all done. Now, all we're looking for is what to add, what's not included. Okay, this, not included, so I'm going to add that. This, check, we got. X, check, we got. x minus 5 we now have, so this is my common denominator. Each one of these has those part of those pieces, nothing is missing. Now in all of these they're going to add something, right? What is this one missing? The x minus 5. So we would have to, what we're going to do next is multiply that one. Okay, what would be left here? Well, these two are taken care of, so these two would have to go to this one. This one has these two would need to be added in. Okay, but we're not going to just simply add. Okay. So we are going to, so if you didn't get that one, I want you to go ahead and try this one. Pause the video if needed. Okay, so welcome back. Let's see how we did. We're going to factor out a 10, and we get x squared minus y squared, which is indeed x minus y, x plus y. That is the difference of two squares. Okay. In this one, we have a 15 and an x, and so what's left over would be an x minus 2y. Oops, sorry, there's a 50. I missed this. It's all the way. Cancel that out. Okay, so what's common in all three of these? We would have a 15 I can factor out, but nothing else. So we got x squared minus 2xy plus 1y squared. Okay, so we're going to factor this. We can actually factor even with the variables. We got 1 and negative 2. So what multiplies to positive 1 adds to negative 2 would be negative 1 and negative 1. So we would have x minus y. Now, how do I know the variables? Because what would give me an x squared is the x. What would give me an y squared? There must be a y in here. So remember, when we're multiplying, right, that's how I would get my xy, xy. There's my two terms. Okay, there's that one factored. This one then. Okay, if I factor out this, there's nothing in common, so we're going to go to this. We got 2 and 3, which would be a 2 and a 1. Similar to this one, we should have an x now plus 2 and an x plus 1. Now, that's where these come in. But I notice I don't have the y, so that's why I'm going to bring in the y. Okay, so the x is normal. The y is what a lot of people get confused on. When I look at it, oh wait, I'm missing a y. That's why it goes in the second spot. Okay, so if we look now, what is common in all of them? Okay, so first off, it's got to be all of this, right? So I'm going to start with the green. We got 10, we got x minus y, we got x plus y. It's got to be everything. Now, what do we need to add? Okay, well, the 15. So this 10 and this 15, right, we have to find a common number that both go into. So it's no longer 10, actually, but what does both 10 and 15 go into? And that would be 30. So that is how we incorporate the 15 and the 10. Now we got the x minus y, check. I am missing a second. There are two of them, so I need to bring in a second one. Okay, now over here we have an x plus 2y, not in here. So we're going to bring in the x plus 2y. The x plus y we already have, and so there is your answer. Okay. All right. Now, how do we actually add and subtract? Okay. So, we are going to do the same thing that we have done so far all the way. What we've been practicing is steps 1, 2, and 3. Okay? Or steps 1 and 2. Now we're going to bring in step 3. Then it's going to become like we did earlier. Okay, we're always going to state the domain, and we're going to simplify if possible. So first thing we want to do is factor our denominators. Okay, so go ahead. I hope I've given you some time to write this down. We got example 3. Otherwise, pause. Okay, if I factor the denominator, we would have x minus 1, x plus 1. And now if I go what multiplies to 2 and adds to negative 3, we get negative 2 and negative 1. So I got x minus 2, x minus 1. So what I'm going to do over here is I'm going to say, okay, what is our least common multiple? What is in all of them? Again, we need everything from the first, and then we're just looking for what needs to be added. Okay, well, we already have the x minus 1. We don't have the x minus 2. So that means this whole thing is going to now be my big denominator. So I'm just going to write this at one time because otherwise they get kind of long. And now we're going to go. Okay, so we have this x plus 3. Remember, it's a group. Now, what part is missing in this one? We had the x minus 1, x plus 1. We need this x minus 2. So this is really what we are doing. Now you can see 1, 2, 3, 1, 2, 3. So I need to multiply this top by an x minus 2. The plus sign is going to go here. Okay, now what is missing from this group would be the x plus 1. So we would multiply by x plus 1 over x plus 1. So that means we have 2 times my x plus 1. Okay, that's the hard part. So that's the rewriting. That is step 3. So we factored the denominators. We found the LCD in red. We rewrote the fractions. Now we're just going to add or subtract. So regardless of if this was an add or subtract, it would be done the same. So we are going to combine. We got to distribute and combine like terms. So on the top we have x squared minus 2x plus 3x minus 6. Second part, we got 2x plus 2. The denominator, remember, stays the same. You're not going to multiply the denominator out. Too much work. Okay, that is going to equal, we got x squared. We have 2x, those cancel out, so we got a positive 3x. And we have a negative 4. Okay, so we now added and subtracted our fractions. Step 4. What we want to do now is state the domain. Where is the denominator? We cannot have it equal to 0. So that is when x cannot equal 1, negative 1, or 2. Right? Because we would set those all equal to 0. Okay, I'm giving you time to write that down. Okay, our last step is to simplify if possible. Okay, so all that means is we're going to check the numerator. Does this factor? And we got a negative 4 and a positive 3. So what multiplies to negative 4 and adds to positive 3, it indeed factors. So now this becomes a problem like we did a little earlier in this topic. And so we are going to simplify out, and we get our final answer of x plus 4 over x plus 1, x minus 2. Okay, pause the video if you need. Okay. Okay, then last one is we are going to subtract. So same thing, now we're just going to subtract and see what we get. So I want you to pause the video. I want you to factor the denominators, find the LCD, and rewrite them with the LCD. Okay, welcome back. If we factored this, we should get x minus 8, x plus 2. Here we should get x plus 4, x plus 2. So our LCD, we would have x minus 8, x plus 2, and an x plus 4. So what is missing from this one? We are going to multiply this one by an x plus 4, and this one by an x minus 8. So now this is where you can save a little time. I'm just going to distribute this right away and get x squared plus x plus 4x plus 4. This is going to be all over our LCD. Now here's the trick. We have a minus here. So I'm going to write this one down. Minus the x minus 1, x minus 8. It depends. There's a couple of ways to do this. But this is always the hardest part, is this minus. Okay? So we can either incorporate it right away. So I'm going to distribute. Now you just have to do it to one of them. Okay, so you could automatically go plus a negative and distribute a negative, or we can group these up, which is what I'm going to do because of how I have it written. Okay, so we have in this, I'm going to simplify this side, and I'm going to go minus, and I'm going to go parentheses x squared minus 8x minus x plus 8 all over my denominator. Okay, now I'm going to distribute this. I'm just going to add the opposite. And now my parentheses should go away. So all I did was really distribute a negative 1 into my x squared minus my 8x minus my x plus my 8. That's all I did, was distribute this. Okay, so I have x squared minus x squared, gone. I have 5x plus an 8x, 13 plus an x, we got 14. So done, done, done. I'm just going to cross them off. We got a 4 plus a negative 8, so we got minus 4. Okay, all over our denominator. Now here's where you can be a little proactive and go, okay, I can take a 2 out, but that would leave me with a 7x minus 2, which I do not have on the bottom. And so this is my answer. Now before I simplified, if I were to cross anything out, don't forget to do your domain. So our domain is where these would be 0, which x cannot equal 8, negative 2, or 4. Okay. Alright, that concludes our lesson on adding and subtracting rational expressions.